There are moments in astronomy that do more than reveal new objects in space. They transform the way we think about the universe itself. The first images from the Vera Rubin Observatory are one of those moments. At first glance, they appear to be breathtaking photographs filled with distant galaxies, glowing clouds of gas, and countless stars. But the longer scientists examined them, the more extraordinary they became. These are not simply beautiful pictures. They represent the beginning of a completely different way of exploring the cosmos. Instead of taking isolated snapshots, this observatory has been built to watch the sky over and over again, searching for every change, every flash of light, every moving object, and every hidden event that would otherwise pass unnoticed. It is designed to turn the night sky into a living record of an ever-changing universe. That mission makes the Vera Rubin Observatory unlike almost every major telescope that came before it. Many famous observatories focus their attention on one small target for hours, days, or even weeks, collecting incredible detail from a tiny region of space. Vera Rubin follows a very different philosophy. Rather than staring deeply at one location, it repeatedly scans enormous areas of the southern sky, returning every few nights to search for anything that has changed. The scale of this project is difficult to imagine. High in the Chilean Andes, where dry air and exceptionally dark skies create ideal observing conditions, the observatory houses one of the most advanced astronomical instruments ever built. At its heart sits the largest digital camera ever designed for astronomy, containing more than 3 billion pixels. Every observation captures an astonishing amount of detail across a huge portion of the sky, producing an uninterrupted stream of scientific data. For centuries, astronomy has largely depended on still images. A telescope would photograph a galaxy, a nebula, or a star cluster, allowing researchers to study what existed at that particular moment. While those observations transformed our understanding of the universe, they often captured only a single instant in time. The Vera Rubin Observatory introduces a completely new approach. By returning to the same regions again and again throughout the coming decade, it will create an enormous time-lapse record of the cosmos. Variable stars will brighten and fade. Exploding supernovas will suddenly appear where nothing was visible before. Asteroids will drift silently across the darkness. Even subtle changes that once escaped detection will become impossible to ignore. This is why astronomers describe the observatory as much more than a powerful camera. It functions as a continuous monitoring system for the universe itself. Every repeated observation adds another piece to an ever-growing archive, allowing scientists to compare the sky night after night and discover events almost as soon as they happen. The very first public images demonstrated exactly why this mission is so important. They were not released simply to prove that the telescope was operational. They revealed just how much information this remarkable observatory could capture in a single glance. Vast numbers of galaxies, intricate structures of glowing gas, and countless celestial objects filled each frame with an amount of detail that immediately exceeded expectations. Those first observations hinted at something even more exciting. The universe is far more active than it appears when viewed through occasional snapshots. Everywhere astronomers looked, there were signs of motion, evolution, and change waiting to be uncovered. And with every new scan of the sky, the Vera Rubin Observatory promises to reveal another chapter in that unfolding story. The journey begins with one of its most spectacular first targets, a region of space packed with galaxies on a scale that challenges the imagination. One of the observatory's earliest released images focused on one of the richest regions of the nearby universe, the Virgo cluster. At first glance, it resembles an endless sea of tiny points of light scattered across the darkness. But that first impression barely hints at what the image truly contains. Most of those faint specks are not individual stars. They are entire galaxies, each one home to billions, and in some cases trillions, of stars. Every glowing island of light represents its own cosmic system, complete with planets, gas clouds, black holes, and histories stretching back billions of years. What makes this observation so remarkable is not simply the number of galaxies visible in a single frame, but the incredible level of detail preserved across such an enormous area of the sky. Graceful spiral galaxies wind outward with delicate arms filled with newborn stars. Massive elliptical galaxies dominate the centers of crowded regions. Others bear the unmistakable scars of past collisions, their shapes stretched, twisted, and distorted by powerful gravitational encounters. Looking deeper into the image reveals even fainter galaxies hiding far beyond the cluster itself. Their light began its journey toward Earth long before our own planet existed, offering a direct glimpse into an earlier era of cosmic history. Every additional layer of depth expands the image from a beautiful photograph into a map of the universe across both space and time. This combination of scale and clarity is where the Vera Rubin Observatory stands apart. Many telescopes can reveal extraordinary detail by focusing on a relatively small section of the sky. Rubin approaches the challenge differently. It captures immense regions while still preserving the fine structures that astronomers need to study individual galaxies and their surroundings. That broader perspective allows researchers to understand relationships that would otherwise remain hidden. Instead of examining one galaxy in isolation, scientists can investigate how entire groups evolved together, how gravity shapes their surroundings, and how galaxies influence one another over billions of years. Some galaxies appear peacefully undisturbed, while others display long streams of stars pulled outward by ancient encounters. A few seem locked in slow-motion collisions that will eventually merge them into entirely new systems. These interactions reveal that galaxies are far from permanent structures. They constantly evolve, exchange material, and reshape themselves under the influence of gravity. To astronomers, images like this contain far more than visual beauty. Every galaxy contributes valuable information that helps scientists investigate some of the universe's biggest mysteries. By measuring the distribution and motion of galaxies throughout massive clusters, researchers can trace the hidden influence of dark matter, an invisible substance that cannot be observed directly but reveals its presence through gravity. The image also provides clues about how enormous cosmic structures formed over billions of years. Clusters like Virgo are among the largest gravitationally bound systems in existence, acting as laboratories where astronomers can test models of galaxy formation and the evolution of the universe itself. Perhaps the most striking realization comes from stepping back and appreciating the sheer scale of what has been captured. A single image contains millions of distant objects, each with its own story, all woven together into one enormous cosmic landscape. It reminds us that what appears empty to the naked eye is actually overflowing with structure, motion, and history. And this is only the beginning. The Vera Rubin Observatory will return to regions like the Virgo cluster again and again throughout the next decade. With every new observation, subtle changes will emerge. New explosions will appear. Variable stars will brighten and fade. Moving objects will quietly cross the field of view. Instead of preserving a single frozen moment, the observatory will gradually assemble a living record of how this vast region of the universe evolves over time. While the Virgo cluster demonstrated Rubin's ability to map the distant universe on an unprecedented scale, its next major image shifted the focus much closer to home, toward immense clouds of gas and dust where entirely new generations of stars are being born.